Question 2, no? A stone is thrown vertically upwards. Its height in meters above the ground at the time in t seconds is given by. No? And then the question says, determine the initial height. Initial, when we start, every time when we start, we say with our time is equaling to 0. So when we originally start, we're going to say 2.1. We're going to have h of 0, which is going to be given as 32 meters. And then they'll give us 1 mark for that. Sharp. Number 2, they say, determine the time it takes to reach the maximum height. Maximum. The word maximum means differentiate. You know? So we should remember that once we see the word maximum is associated with differentiation. So I'm going to say we have h prime of t, which is going to be given as minus 4t plus 12. And then we say at maximum, the derivative is 0. It's going to be equaling to minus 4t plus 12. You take the 4 to this other side, minus 4 to this other side. It says you have 4t, which is going to be 12. And then you divide both sides. You can divide both sides by 4. No? Yes. If you divide both sides by 4, it says divide by 4, divide by 4. It says t is going to be equaling to 3 seconds. No? So then we go to 2.3. 2.3, they say, how fast? How fast? Yes. What am I looking for? Speed. Speed. Yeah. How fast? How fast was the stone when it reached, when it hits the ground? Yes. So when it hits the ground, basically here they are giving you the h of t, which is equal to 0. Yes. Because it reaches there. So you want to know what was the time when it reaches the ground? Yes. So what was the time when it reaches the ground? We're going to say we have 0, which is going to be minus 2 squared plus 12t plus 32. We can factorize this. No?
Yes, t is going to be 8 and
t
minus 8.
T, it's minus
8.
Minus 8. Other one is
plus 2.
Plus 2.
Yes.
So it did reach the ground 2 times. No?
Yes, but time cannot be negative.
Yes, correct.
Oh, so it reached. So we say t is going to be equal to 8. No?
Yes.
Or t is equal to minus 2. Therefore,
t is equal to 8.
T is equal to 8. So this one is, we just tell them this one is not applicable. But that's not what we want.
We want the time it reaches.
No, we want how fast.
We know when we have this formula.
We have the derivative.
Yeah, we have the derivative. So
yeah, we spoke about this to say which you can either work on the derivative. If you don't work on the derivative, you're going to work on the original formula.
Yes.
So here in this case, we're working on the original.
Minus 20.
You get what?
Minus 20.
Minus 20.
Yeah, it was decelerating. It's called.
What is why we started? I'll take physics. No?
Because we have h prime of 8, which is going to be minus 4 multiplied by 8 plus 12, which is going to be minus 20. Minus 20 meters per second. Guys, I was still fine with that one. Does it make sense?
Right. If they're giving you something.
All right, then we go to 2.4. Okay, last one. They say which we should determine the acceleration.
Guys. Yeah, you need to cut.
Okay, they say which we should determine the acceleration, which is, they told you here, the rate of change of the velocity. So we're going to say 2.4. We have the second derivative, which is h prime prime of t, which is going to be minus 4
meters per second
squared.
Yes.
And then we're done with this one.
Done.